hold on. Let me just fix that. Okay, we should have audio now. Sorry about that. I am paying attention to the chat. You're just a bit delayed. Okay, so everyone can hear me now? Ooh. Yeah, so last minute OBS crashes aside, welcome to a new live stream. It's been, I think, since February that we did a live stream. It's been a while, but lots of stuff going on this week, so I didn't have enough time to prepare a full video. I'm working on some stuff, but it's not here yet. So I thought, like, hey, you can submit questions in a minute. So let's do a live stream. So here we are. As I mentioned in the title of the live stream, this will be mainly focused on LED talk, because lots of stuff going on with LEDs, and well, I recently brought out new controllers, and well, it's getting darker outside, and that is generally the time more people start messing with LEDs. So, you can set YouTube to near real-time. The delay is then 1 second and not 17 seconds. Yes, but then the quality is a lot lower. And I kind of like my quality. So, yeah. Let me see if I can put the chat here and then enlarge it. There we go. When is the time to submit questions? Well, you can start submitting questions now. We're with about 50 people, it seems. That's pretty good. And I'll pick a few of them. We'll write them down, and then we can go over them. I have some topics planned because I kind of want to go through like a whole setup and how you calculate things and stuff like that. But yeah, submit your questions, and I'll see if I address them directly, or that it's going to be part of the larger story I want to do. Because there's a video I've been wanting to make for a while now, but I never get around to it, so who knows, we might do it in a live stream. Now let me see if I can still edit some of my scenes. If OBS crashes again, yeah. Let's see here. Yeah, let's just remove this by program capture, window capture, yeah. So you guys have time to submit some questions. Damn it, why isn't it here? Okay. No idea. Sexy dig quad in the background. What effect is that set to? That is set to the Paletti effect, I believe. Let's see. Oh, sorry, Pacifica. And then with the Sunset 2 palette, and it's a dig quad, so it's distributed over 4 outputs, and they're basically doing kind of the same thing. Hoe praat je zo accentloos Engels, man? Knap. I don't know. I've just spoken a lot of English, and I've read a lot more English than Dutch, actually. And, yeah, I don't know. I'm still a Brabo. But back to English. Do I inject from the dig quad or from the PSU using an inline fuse? That is exactly what the dig quad is for. So you inject from the dig quad. So let me see if something else works. Oh, hold on, I need to copy stuff again. Oh, this is like the worst prepared. Sorry about that. Hold on. There we go. Okay, sorry. So here we have a dig quad and a power supply I've been testing, and I really like this type of power supply. So maybe we'll dive into that a bit deeper later on. So here are the DC output terminals. So we have 2 positive terminals and 2 negative terminals, and I've connected wires from those to the input terminals on the dig quad. Now, if you have 1 terminal, 2 terminals, or 3 terminals for positive and negative, just hook those all up, because that's extra copper, so extra, well, power and less heat and less resistance, and we can hook up 3 positive and 3 negative wires to form the input. Then it goes through the board, it powers the board, and it does all the things, and then the outputs are fused, and the onboard electronics are also fused, because that's this little guy here, and you cannot see that. Not sure you can see that. Anyway, there's a polyfuse on there, so that's already fused. So basically everything on the board is automatically fused, and you do not need an inline fuse from your power supply. I see a lot of people making that mistake. If you have a, let's say, 30 amp power supply, putting a 30 amp fuse between the power supply and whatever load it's providing doesn't do anything, because the power supply has OCP, over current protection and stuff like that anyway. So that doesn't make much sense. What does make sense is if we have 7 output terminals and we have the 5 fuses, and some terminals use 1 fuse, you fuse for what's behind that in regards to wires and LEDs, and then it's a proper situation. Okay, I'm going to start writing some questions down here. Let's see, I ended up setting up 2. Okay, yes, so let me open a notepad. Setting up 2 or 3 60 LEDs per meter LED strip 5 volt. Yes, that is something I would like to talk about. So we'll get back to you on that, Henry. Max distance for the controller. The LEDs are being powered, or the data signal is being level shifted, so it gets about, let me go back to this scene, I think. Yes. Can you still hear me? So it gets about 4.8 to 4.9 volts for that signal. And as long as you have enough copper, that signal doesn't degrade below, let's say 3.3 to 3 volts or something like that, it should be good. In reality, most of the time I use AWG, I think 24, and if it's longer, I just use AWG 18, and I've tested up to 15 or 20 meters, and that's been fine. So, hope that answers that question. And data signal in mind, as long as you have voltage drop under control, the data signal from LED to LED can be just as long as from level shifted controller to LED, because each LED regenerates the data signal with its own voltage, if we're speaking about 5 volt LEDs. So if the LED is being driven correctly and there's not too much voltage loss or voltage drop, it will send out that signal at 5 volt again, all good. But if you're having power issues and you're not doing injection properly, and that LED is like at 3 volts, well, then it will rebroadcast that data signal at 3 volts too, and that might be too low to reach the next pixel if you have cables and stuff like that connected. So as long as you have voltage drop under control, you should be good. Does that explain it, Bill? So we talked about Henry's question. Do you already have a nice install at your place with the Dig Uno and Quad? Yeah, I have lots of stuff using Dig Unos and Quads and Decas and normal quads, Dig Quads. I really should have chosen a different name. Having an analog quad and then a Dig Quad board was the wrong choice. I thought it'd be okay. It's not okay. Everyone is confused. I get confused. So, yeah, well, you know. Okay, let's see. How do you remove and reuse strip once they've been glued down to aluminium profile? At first, they stick like hell, but then can be transferred to another profile. Yeah, it depends on the stick. I know you're talking about on the strip. I know you're talking about Oxma strip, and that has some, I don't know, industrial level power glue on there. I don't know what they made it from, but that's hella strong. So I think those you can probably just reglue as long as there not any grease or anything else came in contact with it. Hold on. If we're talking cheaper LED strip, there is actually glue strips you can buy, and I don't have them in the room right now. Let me get back. Hold on. Hold on. Hold on. So, let me go to the desk view again, if that works. Should work. Go away, quad. There we go. So, there's this type of stuff, and this type of stuff. Okay, this is stuck to the bag, of course. But this is basically just double-sided tape in 10 millimeters, which is often the size of your LED strip. This one is 20 millimeters because, well, I was using it for a different purpose. More about this one in a video upcoming. I just need to finish it. But yeah, just you can get more glue that you can actually just glue on the bottom of it. And that will help it stick again if you move it to a different spot, basically. Well, let me get this away. I know you're on the Discord. Ask me on the Discord. I know those two came through a Quinn box, but just ask me on the Discord again, and I can give you some links for that. Let's see here. Quite like the option of running some effects when something happens, but would like the strip to mostly be warm light of quality. Are there any higher CRI addressable LEDs? Sadly, currently, there are no real good addressable LED strips that have a high CRI for white, so a high quality white LED. There are some things happening in the market, and I'm watching those closely, and I'm trying to get my hands on some prototypes and stuff like that, because I'd really like a CRI 90 or CRI 95 RGB strip. That would be insanely cool, because that would just be best of both worlds. But currently, analog is still way the best for warm white and high CRI, and then digital is fine for colors and effects and accents and stuff like that. So yeah. Dig into it more, yeah. If you wanted to run 2 lots of 20 meters of LEDs off the board, would you go 12 volt or 5 volt addressable LED? Well, I actually have a part of that planned for the video. I was thinking about 5 volt or 12 volt LEDs in long distance situations. So we'll get to that. And going old school, I have 25 Quinn Deca boards for BLE temp and LED channels. I had to rewrite some of the libraries, and it seems to be very stable now. Whoa, 25? You have more than I have. That's really cool. Did you rewrite some ESP home libraries, Perry, or did you write your own software? What did you do? Let me know. That's cool. I recently bought a lot of Cobb internal light panels with different voltage input. Is there a way of creating a drive that will take various inputs plus the PWM output? Yeah. So I use some constant current CC Cobb LEDs, but if you do that, that's kind of a hack, using those on constant voltage, as you probably know. Yeah, there's no real good way to do it unless you get a CC driver per LED, because they all have different requirements, basically. It's a bit too much to go into this stream. We can talk on the Discord about that. But yeah, CC, so constant current with Queen LED stuff is difficult at this time. I've looked into creating some CC stuff, but it's a very different world than the constant voltage stuff we do with the Queen LED Quad and Deca. And yeah, that just makes it very hard to design one solution that does all of it, basically. Yeah, if you have a constant voltage cob like Tiska, you showed me the links he had, then that can work. That's no problem, because that's constant voltage, so that's good. So what I wanted to do today is basically go through one or two scenarios of having LED strip. Let's say you want 10 or 20 meters of LED strip, and what things you need to think. I'm doing the hand thing again. What things you need to think about when setting that up, calculating it. How many wires do you need? What thickness does that wire need to be? And how do you figure that stuff out? So basically from designing the setup to calculating the setup and what you actually need. Matt Ortiz writes, just get my hands on Dig Uno and have 50-50 RGB. What's the wiring for it? Well, if you have 50-50 RGB and it says RGB on the strip for the connection poles, so that'd be 4 wires, RGB and then positive, you have analog LED strip, and that's not going to work with a Queen LED Dig Uno. You need a Queen LED Quad, non-dig, for that. But we can figure out what kind of strip it is. Easiest would be to drop it on the Discord. Speaking of the Discord, do I need to make a new announcement? Yeah, let's make a new announcement. Everyone, we're live. I really enjoy the Discord. I really have a good time hanging out with you guys and, you know, walking through some setups, seeing all the things you've done with the Queen LED. That's awesome. And, yeah. Let's see. I'm stuck on injecting power for 12.5 meters right now. That's going to be a thing we'll go through. I just bought a bunch of lithium-ion 18615 batteries for some mobile LED projects. Have any experience or pointers? I've heard lots of WS2812B will run off the 3.742 volts. Could also do 2 in series and buck. Poor. That's a bit too specialistic to go into right now. Again, best to ask that at some point on the Discord, I think. Because then we can sit down and talk about it and see what needs to be done. Alexa, make me popcorn. Did I trigger anything? That'd be cool. Okay. So I need to try and edit something here. It wasn't working just now, but we can retry that. So bear with me for a little bit. Yes. Yes. Does this work? Nice. Okay. So now we should have a paint.net window here. Do you guys see that? Oh, I need to resize it slightly. No, I need to move this down. This is like the most prepared live stream in all of ages. Okay. And I need to make another scene. Because we need to do calculations. And let me just go here, click here. This is so gonna crash again. Let's hope not. Okay, I think that worked. Oh, almost ready. Let's transition. So, can you guys now see my notepad? Let's see, another question. If I put a 60 amp 5 volt PSU in a plastic enclosure outside, in the UK, it can get cold at night when the sun comes out. It condenses in the box, which could... Yeah, okay. Generally with electronics, if they are running, they shouldn't condensate. Because if they're running, they generate a little bit of heat. And the power supply will generate a little bit of heat. And especially if the LEDs are on, heat from the power from going through the board will generate a bit of heat. And the heat will keep the condensation away. So, how do I know this? Well, we do Camp Zone every year, and there we have about 1,500 PCs running all through the night and during the day and every time, you know. And we get condensation too. But basically what we say is either turn off your PC before you go to sleep, and then don't turn it on until like 9 or 10 o'clock in the morning when the condensation is gone, or just leave it running and then it'll sort itself out, and we've never had an issue with that. So if you have a box, even if it's ventilated a bit, as long as moisture isn't getting in there and the electronics are running, should be fine. So, as I said, I wanted to do... Oh, I can't type here. I wanted to do some scenarios. So let's make a scenario. Let's say... let's see if I can do this. I need to point myself. Oh, sorry, but no, don't do that. Okay. Yes, great. Nope, other way. Yeah. So, and let me know if you can see me type. You should be. Scenario 1. We want 15 meters of LED strip for in my room. Okay? Yeah. And scenario 2. Well, no. Okay, I'm going to make 1A. We want 5 meters. And then scenario 1B. We want 10 meters of LED strip for in my room. And then scenario 1C. We want 15 meters of LED strip in my room. I saw this on TikTok. Why is it so hard? Does anyone know what I'm talking about? Okay. And then let's do scenario 2. I want 30 meters of LED strip outside. Sure. I've been to Camp Zone twice. Long time ago. Good fun. Ronald T. Cool. Nice. What's that chat platform you have on the screen? You mean just the chat over there? That's just a website I use to capture the YouTube chat and then display it in OBS. Hey Thomas. I've already set up 4 QuinLED quads and 4 decats and 2 Dig Unos. Changed everything over to QuinLED boards and have a bunch of Me-Light controllers for sale. Yeah, I remember you doing that. That's nice. Okay. No, I can't click on OBS. Okay, so for this we need, or we're going to use 1 roll of 30 LEDs per meter, WS2812B, right? So 5 meters, 30 LEDs per meter, because we don't have a lot of money. And, well, the first question we need to answer is, how much power will that use? Because 150 LEDs in total. Let me start saving this before, everything crashes and it's all gone. Okay, so we're going 5 meters and we want to do one roll of 30 LEDs per meter. So 150 LEDs in total. The first thing we need to do to figure out this situation is figure out power draw. Now we have a... No, we don't have a chrome window. Do we have a chrome window? There it is. Nice. Okay, so we go to my website, quinled.info. I suppose everyone's been there already. And there we have the digital LED power usage sheet. I recently did some updates for that, and I split it between a 5-volt sheet and a 12-volt sheet. But we're going to use 30 LEDs per meter WS2812B, so that's 5 volt. So let's take a look here, and we see the following values. Pure red uses 25 watts, and 50% uses 15 watts. And pure white, or RGB white, because we don't have a pure white, because, well, we don't have a dedicated white channel, uses 65 watts. Now, if you want to be the safest person on earth and you run it full power, you can design it for 65 watts. But if we look at the effects I also test, the Police All uses 25 watts, so that's less than half than 65. Then the Effect 2 Loading uses 11 watts, so that's like 1/5 of 65 watt. And then the Effect 3 Rainbow at 100% power also uses only 25 watts, so again that's about 1/3 or something like that from 65 watts. So generally with 5 volt LED strip, when calculating power, it'll use about 1/3 of the maximum power. But let's say the maximum power is 65 watts. So let's, be on the cautious side and say we need to be able to deliver 32.5 watts, so half of that. So, okay, let's say max power is 65 watt. Calculation power is half is 32.5 watt. Okay? So we want to be able to inject 32.5 watt into the strip. Okay. 32.5 watt divided by 5 volts is 6.5 amps. That's still a bit too much, actually. Okay. Now, when doing power injection, our WS2812B always 5 volt? Yes. Sorry, I'm paying half attention to the chat right now. I just want to work through the first scenario. So, when doing power injection, 1 point on the LED strip can generally carry about 3 to 4 amps. So, if we need 6.5 amps, that would mean if we wanted to run these 150 LEDs per meter, or 150 LEDs in total, we need 2 injection points. But we calculated on the safe side. We can do it on a less safe side because we don't want to do all that wiring. So instead of saying, okay, we need half of 65 watts, we only need 1/3. That's 21.6 watts. And then let's see what that is in regards to, because I've tested all of this and I know what kind of works and what doesn't. Yeah, this is more the calculation I wanted to get to. That means we need 4.3 amps. That means that if you have a single 30 LEDs per meter LED strip, you can inject it from one side. So just, let me go to my desk. We have one of these LED strips here, and that means you can just take this side here, inject, connect your controller to that. Oh, we have a controller right here. Aha. So we have a controller here. Connect it like that. Well, not this one, but no, we need to use the other one. Actually, well, whatever. You connect those together, and then for 150 LEDs, you're fine. Okay? Does that make sense? Does anyone actually understand the calculations I just did? Let's hope so. Moving back, I'm going to adjust this one to... I'll publish this text document on my website later on. Okay, so basically scenario 1B will be this exactly the same. We again have 5 meters of LED strip, but now we're not using 30 LEDs per meter, but we're using 60 LEDs per meter. Okay, let's see what that does with our power usage. Oh. See, I did it all wrong. Does anyone know what I did wrong? Oh, wait! Mark Chadwick, you are paying attention. I couldn't figure out why it wasn't panning out, because I know these calculations. My sheets, and if you look here, it's right there, are for 60 LEDs per meter and or 300 LED... Oh, I'm not showing you the... Right. For 300 LEDs in total, or 60 LEDs per meter. So, I just calculated it all wrong, because I took those values for 30 LEDs per meter and 150 LEDs. Okay, well, that's my bad. So, let's do it again. You know, that's why this is a live stream. I get to work through my problems with you. So, instead of this using... Oh, I can't click here. That much, we're going to move this one over here, and this is going to be 32.5 watts. Okay, now half of that, because I do like calculating with half of that, is 32.5, 16.25. 16.25 divided by 5 volts is only 3.25 amps. Okay, 3.25 amps we can easily inject on one end. As I said, most LED strip will take and transport about 3 to 4 amps from a single injection point. So for this you can just hook up one side like I just showed you, and that will be fine. But what if we move on to the 65 watt scenario, where we do actually have 60 LEDs per meter or 300 LEDs? I was thinking, why doesn't this pan out? I was just doing my own calculations wrong. Thanks, Mark. So, let's do that again. Calculation power is half, is, let me put in my calculator, 32.5 watts, okay? 32.5 watts divided by 5 volts, still, is 6.5 amps. Okay, and this is kind of the point where I wanted to get to. If you're running 150 LEDs, you can do this with a single injection point and run maximum brightness. No problem. But if you're running 300 LEDs, and be that 2 strips of 150 LEDs or 1 strip of 300 LEDs, one injection point isn't enough anymore. You can still get away with it if you use the power limiter in WLED, for instance, and basically just lower the power limit. Let me do something real quick. Oh, there we go. And basically lower the power limit so that the amount of power you're going to use lowers. That means the voltage drop will also lower slightly, and then you can get away with that. But if you want to run full power effects, we're not talking white, because white uses too much power. If you want to run full power effects, you need to do 2 injection points. So if we go back to the desk again, you need to basically inject at the front. Oh, let me put it over here. At the front and at the back to run 300 LEDs at maximum brightness for effects, like is in our sheet. I mean, it's like right here. It says we need, well, about 25 or 30 watts to run these effects for 300 LEDs. And if we only inject at a single point, we can only generate about 15 to 20 watts, or we can only get that into the strip. So that won't be enough, and you'll get too much voltage drop. Does that make sense? I'll pay attention to the chat for a little bit. So, for 150 LEDs, let me just add this here. Single injection point is 3 to 4 amps. One-time injection, okay, right? Single injection point is still 3 to 4 amps. 2 times injection, no, one, okay, that's just the injection is slightly limited. Limit total amount to 3 or 4A. All right. 2 times injection point, front plus back or end. Is okay. Does this make sense? Do I have anyone left in chat? Let's hope so. Or in the middle. That's a good point, high-tech too. If you can't inject front and back, the reason is you basically lose power over the strip. And if you inject 4 amps here and it needs to travel here, it loses power over along the way basically. But if you can inject in the middle, it has the strip material to distribute that to the outside parts. That is also fine. So then you can get away with a single middle injection point. I'll just add that. 1 times injection middle is okay. That's a very good point. Let me fix this. My voice always starts crapping out. Will E says 600 LEDs at 5 volt with middle injection only right now. Okay, but then you're either using brightness limiting or you're losing brightness and color accuracy and basically experiencing voltage drop. Because I've tested it, it just doesn't work. You cannot inject more than 3 to 4 amps at a single point. Even if it's the middle, you can double that up because power goes both ways. But even then, if that's the middle of 300 LEDs to the left and 300 LEDs to the right, you still run into the same problem that the strip has too much resistance and it will start dropping voltage. Now, it depends on how many LEDs are on if you're going to see that, and you might get lucky because if you use, let me take a look at the power chart again. If you use a single color, we're only doing 25 watts. But if you're doing a double color, so like red is a single color, blue is a single color, but purple is a double color, that will use more power. And the effects also use more power. So you're going to see that. Or, well, if you pay attention to it. I guess analog LEDs have the same values? No, analog LEDs work a bit different because you don't calculate per LED. And also you can get those, for instance, in 24 volt, which makes the whole thing a lot easier. And with analog LEDs, it's hard to tell how much each LED will use, which we can do for digital LEDs. With analog LEDs, I mostly say if you get a high quality strip, so like the color diode and the Oxma strip I often link to on quinled.info, you can go with 24 volts about 2.5 meters before you need to inject again if you want to get perfect brightness. Or if you run never above like 70% or something like that, you can do the whole 5 meters without an issue. But that's because it's 25 volts. Does each injection point mean a wire from the quad, or can I split the wire from the quads? Are we talking dig quad or analog quad? Because these power calculations are all for digital LEDs. Wouldn't it be great to see a higher voltage individually? Oh, my voice is crapping out again. Hold on. Okay, and we're back. Yeah, higher voltage LEDs. We're going to talk about that in scenario. Let's do that scenario. I don't know. I keep editing these scenarios anyway. So, we now did scenario 1 and see that one injection point is fine. We can run our effects at full power. And scenario 1B, we can either do a one injection point in the middle. Very good remark. Or we can do two injection points, front and end, and that will give us a fine average voltage too. Okay. Now let's go to C, and we want to do 10 meters of LED strip. Okay. And let's divide that in 30 LEDs per meter and in 60 LEDs per meter. Okay. Now, max power is 65 watt, because this is 2 times 150 LEDs, and for this max power is 130 watts. Okay. I'm running 10 meters with middle injection right now. Yeah, well, have you tried setting that to a double color, your effects to full color, or even to white? Because you'll definitely see a drop off. But it depends what you set your power limiter on in WLED. If you basically set your power limiter to half of what the LEDs can do, you limit it to half brightness, but you won't see the drop off anymore because, well, you're using less power, so there's more to distribute over the strip. Ronald says, interesting, got the Oxma 24 super bright for in the kitchen. No idea how bright they'll be. They're very, very bright. So hopefully you won't run them at 70% or higher at any point. No power injection over 4 meter would be ideal. Just look at it and see how it works out. Oh, sorry. Switch OBS-C to Notepad again. That's a good one. Is each LED 60 milliamp on full white? Good question. No, it's not. I know that's the general value people tell you to calculate with, but I have some sheets on my website where I do real-world calculations, and there you see that 300 LEDs use 65 watt. So 300 or 65 divided by 5 is 13 amps divided by 300. That's 0.043 watts for each LED perfectly fed on white. So no, LEDs do not use 60 milliamps per meter. That's like the uber worst case you can calculate with, but that's not real world values. And I also want to argue that you do not want to run RGB LEDs at white because they get really hot and white looks like shit. So calculating with half is often a very good value, so you can do full power effects, full power single or dual colors often, just not white. But we don't want to run white. So. And it also depends a little bit on the type of LED you get. That's why I have the WS2812B, WS2812B Eco. As you can see, the blue uses a lot less power here. SK6812 is a bit different again. APA 102 uses a lot of power. And I have a separate chart for 12 volt. So calculate with the charts and the real world values, not that 60 milliamp per LED value. That's just someone sometime threw on the internet. And no, it's the theoretical maximum, but no LED strip I've ever encountered actually uses that. So you'll be using a lot more copper and over designing stuff, which really isn't necessary. Oh, Glenn Brown, any news on 12 volt RGB W with backup channel? I watched your SK6812 volt video. but would still love to see a version with a backup channel. I do not know if that exists. Currently, I don't think so. But manufacturers are always working on stuff, so who knows. I measured that voltage drop is higher if the LEDs are at full brightness. Can you explain why that is? Okay, sure. Kind of mentioned that earlier. If you're trying to push 10 amps through a strip, the amount of resistance you encounter is for those 10 amps. So if the first LEDs get those 10 amps, it's not available anymore because of the resistance, and thus the voltage drops for the later parts. But now if you set all LEDs to 50%, that means the LEDs at the front also take less power, so less resistance gets generated, and thus the same it's able to travel further because it encounters less resistance in the beginning. That makes sense? Basically, if you imagine a pipe that water flows through, if you put in pressure and the pipe is this wide, that pressure will start decreasing a lot quicker than if you put in the same pressure but the pipe is this wide. Does that make sense? What is your favorite LED strip of choice? It's this one. And it's something different than all of you think it is. There's going to be a dedicated video about that. But maybe we'll get to that in scenario 2 or 3. Let's get back to the scenarios. So we said, okay, we're going to do 10 meters. So 30 LEDs per meter is 300. And then this is 600. No. Yes. Let's call this projected power. I think that's easier. So once you know how much power it actually uses, it becomes a lot easier. So in this case, 32.5 watt divided by 5 volt is 6.5 amps. We knew that from our previous scenario. So basically, it says, well, single injection point. I keep clicking in OBS window. It's really starting to rain outside. Can you guys hear that? Been wondering about that. I've actually not recorded at some points when it was raining like this. So if I wanted to have white LEDs in my living room at 100% brightness, would you not recommend SK6812 RGBW? Yes, that's a very good point. If white is important for you, even though it's not the greatest white in the world, get SK6812 RGBW LED strip, because that white is a hell of a lot better than RGB white, as I call it, so red, green, and blue at the same time. Very good point. And the dedicated white channel also uses a lot less power than combining all the LEDs. Because if you see here, we have SK6812. LEDs RGB white uses 49 watt for SK6812, not 65 like the WS2812B. Okay, but the dedicated white channel only uses 35 watts. Okay, so if you want white, if white is important, get RGBW SK6812. Absolutely. If it's primary lighting, so not accent lighting or effect lighting or something like that, you need to get analog LED strip for high CRI LED lighting, because it's so much better than even RGBW still. I love my SK6812 LEDs. Nice. Johnny Bergdahl? Yeah, says, it's raining here too. Thought it was just you. So you can hear it on the microphone? I take it that the 12 volt SK6812 RGBW would be less current draw. Actually, we can take a look at that. So this is my 5 volt sheet, and this is my 12 volt sheet. So let's take a look at 5 volt SK6812. 5 volt SK6812. White uses 35 watts. Okay, all the sheets are in watt. Okay. Then let's take a look at where is it? SK6812 RGBW. And white, that I believe is the 35 here. Yep. Uses 35 watt. So both the 5 volt version and the 12 volt version use 35 watt to display white. But with 5 volt, and I don't have my calculator in an OBS thingy, it's 35. I guess I could do that. Hold on. Oh, live editing. Let's remove that. Yes. Program capture. Yes. Now we have a calculator. Awesome. So if we're talking 5 volts and 35 watt, that's 7 amps. Okay. But if we're talking 35 watts at 12 volt, that's only 2.91 amps. So what that basically means is that your cabling will be a lot easier because you need a lot less copper because of the higher voltage. Does that answer your question? I thought I heard your ring, not sure now. Greetings and salutations. Nice to see you live and say hello. Hey Calvin. I've ordered 3 types of SK6812 with warm white, neutral white and cold white for testing. Can't decide which white is the best. Then you should order SK6812 WWA that has warm white, cold white and amber white, and it's all addressable, and then you can make all the white colors you want. It just has no color. Am I in focus? Oh, good enough. I have not made any silicone tubes myself, but I do have a video about one of those neon silicone tubes, and that has a really, really nice diffusion effect. Let me get a drink. I have no clue. Do we actually have any people watching? 92. Nice. Yeah, if you want addressable colors and also have white as an accent color, and you can mix different colors into that and stuff like that. The 6812 RGBW 12 volt is pretty nice strip, and it's actually if we go to Chrome again, if you look here, it's actually quite efficient for what it does, because it only uses 23 watts per color, and then yeah, for the effects also. There is one downside to using 12 volt LEDs, except WS2815 for instance. Most LEDs are per 3 addressable. So that's why it says here, per 3 addressable. You have 300 LEDs, but you only have 100 addressable zones, basically. So each LED in WLED, 3 LEDs in reality will light up. Now, if you're doing long runs, that is a very okay downside, I guess, to take into account. because if it's 10, 15, 20 meters away, you won't see it anymore anyway. But if it's like really close, having individually addressable LEDs is nicer than having per 3 addressable LEDs. But it really depends on the scenario and what you're trying to achieve. That's also going to be my recommendations. Are you going to do 5 to 10 meters? 5 meters, just use 5 volt LEDs. 10 meters, it's a bit in between 5 volt and 12 volt LEDs. And if you're going more than 10 meters, use 12 volt LEDs, even though they are per 3 addressable. Great stream. Thanks. Give it a like. Have more people join. So, back to the notepad. No, back to the drink. Jory P. Hey Quinder, which type of LEDs are you going to use in your Christmas tree this year? Again, those small copper wire ones. And will there be any WWA string instead of a strip available this year? There are WWA pixels available that you can use outside and stuff like that. I actually have a whole box of them for a project I planned last year. It never happened. But I plan to use the colored ones again. Those tiny little Christmas pixels I showed. Let me show you on QueenLED.info. So that's RGB pixels and other LEDs. So last year we used these tiny pixels. Those were great. And I bought a bunch more of those. And I believe I have about 400 going into the tree, 500, I don't know anymore. But that's going to be great. They do require power injection per 2 or 3 strings. But you can work around that, especially now with the dig quad. That's part of the reason why I built the dig quad. But watch my videos about that from last year and it should explain all the things. Hey, Adonna was here. Nice. Oh, nice stream. Nice. Thanks, Wagner Campagner. I don't know how to say that. Notepad. Yes. Let me finish this real quick. So, if we're using 32 watts for 300 LEDs, okay? Is that correct? Yeah, that's correct. Basically, the same thing applies. So we can use one injection point that will be slightly limited. In the middle is probably going to be okay. And 2 injection points is certainly okay. Then, if we scale that up and we say, no, I want that 60 LEDs per meter strip, and I want 2 of them, and, well, let's see what we need. We now need 65 watts, not to do white. For white, we need 130 watts, but to do general colors and effects without voltage drop, we need 65 watts. Okay, sure. Let's see then how that works. Because a single injection point, as we said... Let me fix this real quick. 65 watts divided by 5 volt is... We now need 13 amps. And we said, okay, a single injection point can only handle 3 to 4 amps. So that's starting to become interesting. Hold on. One injection point, well, total fail. They'd either be very dim, have lots of voltage drop. That's not going to work. 1 times middle. 1 times injection. Nope. That's only going to give us 6 to 7 amps. Very limited. 2 times injection, front plus end, that will work, but half of second strip will show severe voltage drop. Because we know that we need 2 injection points per 300 LEDs. So if we only do front and middle, well, the end's not getting anything. So that's not going to work. 3 times injection point. Front plus middle plus end is okay. Does that make sense? So 1 60 LED per meter strip, you need to do front and end. And then if you move on to 2 60 LEDs per meter strips, you need to do front, middle, and end. So 3 injection points. But now we get to a subject I also wanted to highlight. Wait, what cables do I need for this? Because now we're getting into doing actual injection runs. And, well, it's starting to become interesting. Because with 13 amps, we need to divide over 3 injections. 2 of those are edge injections. 1 of those is a middle injection. Now, the easiest way to calculate that is, if I do it roughly, 13 amps divided by half is 6.5 amps. And that means front is 3.25 amps. Middle is 6.5 amps. End is 3.25 amps. Total is 13 amps. Does that make sense to you? So, front, end, and middle. Middle has twice the amount of LEDs and twice the amount of strip material closer to it, because it can go both ways, than front and end. So, logic dictates that if all LEDs are powered on, middle can draw twice as much power as a front or an end injection point. Does that make sense? Let me know in the chat. Can you recommend any strip that has excellent CRI? Go to quinled.info and check out the high quality warm white LED strips. That's only analog LED strip. I do not know of any digitally addressable LED strip that has a high CRI. And here I have a section for premium, good, specialty, and the cheap stuff. Don't buy the cheap stuff. The cheap stuff sucks. Yeah, but premium, we have a color diode and Oxma. They're both on the same level or tier or class. Oxma tends to be slightly cheaper and they have more options. So I tend to recommend Oxma nowadays. But they're both excellent strips, and I've done my own measurements with my colorimeter or spectrograph, and they are absolutely excellent and really do adhere to the specifications they give you. Okay. Hold on, man. I don't believe I'm made for talking. So yeah, I do recommend those tiny pixels for in the Christmas tree. The amount of power they use, I believe it's max 15 watts for a strip of 50 pixels. But check out my Christmas tree preparation video. It's all in there, including the power usage and the power injection tests and stuff like that. So check out that video and that should give you all the answers you need. Do you have adjustable LED strip with better copper wire inside? Yeah, I guess they could make that, but they basically don't. Most LED strip is made the same. Just with analog LED strip, I know there's definite quality difference in strip material. So Oxma and color diode really use thicker copper layers, so you can actually see those. But for digital LED strip, I haven't really encountered it. And if they do make it, it's probably such a niche product that the price isn't going to be worth it. Because if it's $25 for the normal version and $100 for the non-power injection version, well, you can add wires for $10. So it's probably not going to make sense financially. Middle also has twice the amount of wires. 2 from each strip. Do you join the 4 with the... Yeah. Yes. So middle indeed has wires from the strip coming in and the strip going away. And you basically add a set of wires to that and connect them to here and connect them to here. Like with a Wago clamp or block or something like that. Yes, calculation makes sense. Excellent. What is the Best Buy white LED strip? Oh, well, we already showed that. Meaning 2 from strip 1 and... Yeah. Meaning 2 from strip 1 plus 2 from strip 2 plus 2 from the dig quad? I'm not sure I follow. If we're talking power injection, let me go to my... Now you guys are going to see something. I'm going to do drawings with a mouse. Oh, man. So let's say we have a dig. Oh, this is so cringe. Okay, cool. Oh, yes. Excellent, excellent. Let's say we have a dig quad, right? Oh, man. Oh, God. Okay, and now we have a LED strip. And I'm just going to call this as an LED strip. Then from the dig quad, we need a red wire to here. We need a green wire for data. And then we need a black wire for ground. Okay, so this is the single injection scenario. So for 30 LEDs per meter. So let's say this is for 30 and this is okay, right? These are like the worst drawings on the internet. Okay. Nope. Yes. Okay, now we have 60 LEDs per meter. I know there's a tool for drawing squares. Okay, for 60 LEDs per meter, we said we needed... Okay, we need another injection wire. Nope, wrong color. Okay, let's do negative first. And that goes here. Nope. Okay, does that make sense? You can use a Dig Uno for this because you can just jam 2 cables into the output terminal or use a thicker cable on the output terminal and then use Wago clamps like I've shown in some videos. But that is part of the reason why I introduced the Dig Quad. It has lots of output terminals, so you can do this easier. Let's also do the other scenario we just talked about. Nope. Yep. Okay. And that is 2 times 60. And that means we have another LED strip here. Okay. That means we need to add a wire to here. But that's... sorry. That is actually not true. Because it's already here. Where's my eraser? There it is. No. Okay. So what we say now is that this wire goes here. Need to use black. And from here, it goes here and there. Okay, does that make sense? And there we go. 2 times 60 LEDs per meter. Let me just write that there for prosperity. Let's save this masterpiece before it gets lost forever. So I know the drawing skills are like other crap, but does that make sense? Does that make you understand better how to do power injection? Drunken live stream tutorials going from sober to wasted? I don't drink. I don't know about that. Dr. Quinn. Yeah, well. Gijs Einde, goedenavond. Jij nou ook al live? I think the reality was live tonight too, right? $12 as you can do, then you can do 2 times 5 meter like that on the bottom image. Oh wait, let me add 5 volt. Oh, that's too big. There we go, perfect image. Okay. Alfred Dawns says, different topic. Tactic. How many SK68 12 pixels can you run through a single dig Uno? What is the amp limit? How many Unos can you link together with WLED and or X lights? Well, the amp limit is pretty easy. Let's go to Chrome. And we go to my website. This one, yep. And then we go to the Quinn LED Dig Uno. It's over here. And then we scroll down. And then it says power handling. Maximum sustained power input and output through the board. If you have a 1OZ board, that's about 10 to 15 amps, I'd say. And if you have a 2OZ board, and all pre-assembled versions are 2OZ boards, it's about 25 amps. But that I'd adhere to as a maximum rating, let's say 15 to 20 amps. So if you then combine that with the power usage sheet for SK6812, and you know the watts, you can calculate how many LEDs you can run through the board. But there is a value we haven't talked about yet, and that is the total amount of LEDs you're going to run. So let's add that to our notepad actually, because total LEDs is 600. If you're running LEDs like WS2812B or WS2815 or SK6812, they all use the same protocol. And that protocol states, protocol limits, about 500 LEDs, you get about 60 frames or updates per LED per second. Okay. Now, if we're running 1000 LEDs serially, so on the same output, we get about 30 updates per LED per second. And another downside is that our data packets are becoming much, much larger. If we scale that up to the maximum WLED currently takes, that's 1500 LEDs, you're down to 15 updates per LED per second. 15 updates per LED per second is fine for a single color, but doing any effects, 15 will look horrible, 30 will look choppy, in my opinion, and 60 is excellent. That is another reason I developed the Quinn LED DIG Quad. It has 4 data output terminals, and each of those can do these values. Now, with that said, about 600 LEDs, we're going to do about 55 frames per second or updates per LED per second. That is still fine. That's okay. You won't really see that. But going to 1000, you will really see. So that also makes the scenario interesting if you're going to say, I don't want 10 meters of LEDs per second, or LEDs. I want 15 meters of 60 LEDs per meter. That goes, scenario. What's the scenario? Scenario? Okay. That makes it very interesting because, 2000 in this case? Yeah, 2000, do not run 2000 LEDs on a single output channel. It'll grind to a halt. It'll basically only do single colors. Because WLED refreshes a single color with 4 frames a second. And the effects it does much higher, but a single static color, it still sends pulses through the LED strip, but only 4 a second. So we can get into, basically if you know scenario 1C, it's very easy to extend this. So instead of, if you're doing 10 meter, you say, no, I don't want a 10 meter, I want 20 meters. Well, then you're going to run into 1200 LEDs. I don't recommend doing that on a single data channel. And you're going to not need 13 amps, but 26 amps. Now the value of the amps stay roughly the same. They become a little bit more per port. But you can easily scale that up if you know these calculations. Let's calculate what kind of cable we need for this. So 4 boards needed then. Yes, you need either 4 DIG Unos or 1 DIG Quad, because it has 4 output terminals. And then you just run the data wires along with the strip. And another advantage of the DIG Quad, you can use the 4 output terminals, have 500 LEDs on each, 2000 in total, but you can set WLED to act as one giant strip with no synchronization or anything necessary. So all effects will run fluently over the 4 different strips as if it's one strip, even though you're using 4 output terminals. If you're using 4 controllers with the sync option and stuff like that, it won't look that great because the sync option basically sends the same effect to that other controller. It doesn't sync them so they have a smooth transition between the two. I already bought the stuff for 10 Unos, so that will need to be the plan. Thank you for your help. Well, the DIG Quad, look through the hardware list because the difference for a DIG Quad or a DIG Uno is very minimal. You can use 90% the same components. But with that said, you can easily build it with a Dig Uno too. That's no problem. Yeah, just giving you the information. Okay, let's do another type of calculation for this scenario. So this was how much power do I need where? And then let's do, wait, what cables do I need for this? But now we can calculate that because we know the values. Our front cable uses 3.25 amps, our middle cable will use max 6.5 amps, and our end cable will only use 3.25 amps again. So we know that front is, let's say, 1 meter, then middle is, let's say, 6 meters, and then end is 11 meters, okay? And then, as we said, this is 3.25 amps, 6.5 amps, 3.25 amps. Drop acceptable is 1 volt, so 4 volt left. So let's say that if you want to do it perfectly, you don't want to drop below half a volt. So I kind of normally calculate half. Okay, sorry, half a volt, so 4.5 volt acceptable. So let's say that our feeding wires need to be able to sustain 4.5 volts with the amps we calculated. So we can have half a volt of drop. Okay, so here we need 1 meter, and over that 1 meter we need 3.25 amps. Okay, let's go to the browser again because I use a little tool. And that's this one. And here we can I'll drop this in the chat. Drop it in the chat. I like using this tool. Oh, the rain has started again. So we said, okay, I don't like feet, I like meters. Sorry about that. I do actually like using AWG. We had DC, we had 5 volt. We need 3.25 volts, amps. And let's say we have an AW18 cable. Okay, that means we're going to have 0.1 volt drop. That's fine. Let's say we use a 22 gauge cable. Okay, that's still fine. Okay, so let's see for this value. Minimum 24 AWG. Yeah, we can calculate that to millimeters square later if you want. Minimum. Oh. So this will be 6 meters and 6.5 amps. Okay. We go back here. We say we now do this 6 meters. We again want 5 volt, but we want 6.5 amps. Oh, what? We have 131% drop. That's not going to work. What if we use 18 gauge? We have 1.6 volts drop. 32%. That's not going to work. 16? Nope. 14? Nope. 13? Yeah, okay. With 13 gauge, we get half a volt of drop, 10%, over 6 meters if we need 6.5 amps. Okay? Let's go back to our notepad. So we need a minimum of 13 AWG. Okay? Minimum. Now we say we need 11 meters, but 3.25 amps again. So 11 meters, 5 volt, 3.25 amps. Okay, let's make it slightly smaller. Yeah. That's kind of in the middle. Let's say 14. Minimum 14 AWG. Does that make sense? Yes, and this is all 5 volt. And this is also the reason why I said 1 to 2 strips, 5 volt, maybe with 2 12 volt. Going beyond 2 strips, you want 12 volt LED strip, because it solves 2 problems. It uses a lot less copper because it's 12 volts instead of 5 volts, so the amount of amps will be lower. But since it's per 3 addressable, it also means the amount of LEDs or addressable zones is lower, so having more strips is no problem because it only uses 1/3 of the addressable zones. But we'll calculate that in a scenario next. Mark R says, again, why 12 volt rules when doing long runs. That 12 AWG wire gets expensive and hard to hide. Exactly my point. Can you add millimeter square as well as AWG? Sure. I always kind of just look that up. Let's see. AWG to... I don't know. This one? So 13 gauge is, let's say, 2.6. Is that correct? I always get twisted with this stuff. And 24 gauge is 0.2. Yeah. And 14 is 2. So that would bring it to this. Oh, no, that's one. Let me know if I did that correctly, because I never know if I'm looking at the right table. I think so. Let me see what another table says, I guess. This one? So 20, no, 12, oh, 14, 208. Yeah, that's what we have, so that's good. Let's see what this one says. AWG 14 is, yeah, 208. So, oh wait, you're not seeing that. Sorry. Yeah, so this is another conversion table, and it says 14 AWG is about 208, and if we look here, 14 is 208, so I think that's correct. And yes, that is thick cable. That is a lot of copper. That's going to be hard to hide, hard to handle. 24 volt rules. That's why I recommend 24 volt analog LED strip. Absolutely. That's why I keep saying these things. Finally explaining why I say these things. Okay, I think this scenario is pretty decent. Let's do scenario 2, and that's I want 20 meter of LED strip in my room. Whatever. TikTok, Instagram, YOLO. And if you know what I'm talking about, you know what I'm talking about. Anyway, so what I like to use, and this is new. Hey, wait, what happened? Oh no, that's not going to fly. There we go. Hold on. I've been looking into what I need to recommend people to do this. And what I've arrived at is using 12 volt WS2811B or 2811 per 3 addressable 96 LEDs per meter LED strip. And that is what I showed you earlier. That is this stuff. So it has the chips here, as you can see. And that is the WS2811 chip, because it's an external chip. And then it has the 3 LEDs per section. Each chip basically powers 3 LEDs. So that's why they're per 3 addressable. Okay? And there's reason why per 3 is a lot more reasonable than per 1. We can take a quick look at that. If we look at our power table, we can see if you look at WS2812 or WS2815 is 12 volt. You have 300 LEDs, and that's also per 300 addressable, so 300 addressable zones. It's really, really inefficient. An LED needs 3 to 4 volts, and if you give it 12 volt, well, that's not going to work. So if you set it to white, okay, you have 3 plus 3 plus 4, whatever. You get close to 12 volt, and then it can use all that power. But now we set it to red. Where does the power, that red LED still needs 3 volt, you're giving it 12 volt. Where does it go? Well, if you do per 1 addressable 12 volt LED strip, it just burns it off. Because we need to drop the voltage, so we just throw it all away. We burn it off. So that's why if you look in my power charts, white uses 48.6 watts, but just red uses 51 watts. Just green uses 50 watts, and just blue also uses 50 watts. So they're just burning the power away because they need to drop the voltage. And that's why per single addressable 12 volt LED strip, it's usable. Actually, that is WS2815, but in longer scenarios, I do not recommend it. Do we have WS2812 in 24 volt versions? Well, then the problem would be even worse. So, if you look here, doing effects, Police All uses the full 50 watts, Effect 2 uses 17.9, and Effect 3 uses 39 watts. That's a giant amount of power. So that's why I say, okay, if we're going beyond 10 meters, let's move away from the per single addressable LEDs and now look at the, let's say, for instance, this one. The 480 LEDs with 160 addressable zones, so per 3 addressable. And this is BTF Lighting high power version, so the bright version. That only uses 40 watts for a single color. So you have 480 LEDs. That's a lot more than the 300 of the other strip. And it's a high power variant, so it actually is a lot brighter. But it still uses less power because instead of burning the voltage off for blue and whatever, it spreads all the power over 3 LEDs, and that drops the voltage for you. That's why they're per 3 LED. And if you have a 24 volt LED strip, that would be a per 6 LED addressable. And that gets kind of, you know, how much compromise do you want to make? So I recently tested a 144 LED per meter per 3 addressable and a 96 LED per meter per 3 addressable. And this is a high power bright variant, and I really, really like it. So if we look here, yes, on white it will use 101 watt. That's a lot of power. But as we said before, we're not going to run white. We're not going to do that. Effect-wise, it uses 40 watts, 23 watts, and 38 watts. So that's very reasonable, especially at 12 volt. That's like 38 watts is only about 3 amps. So let's say we take our 101 watts and we do the same calculations as we did before. So we have a 12 volt WS28 per 3 addressable 96 LED meter strip. Okay. Let's do the same calculations again. Let's just copy this, put it here. So max power is 101 watt. Projected power usage is, as we said, half of that. So that's 50 watt divided by 12 volt. And that makes 50 divided by 12, 4.16 amps. That's not right. There we go. Ah, and here we still have single injection point is 3 to 4 amps that it can carry. So that means one injection, slightly limited total. Yeah, okay. That means one injection is just okay. That will run your effects and single colors at full brightness. It won't do white. White, so we'll see with some drop off. But yeah. So now we have already 450 LEDs a meter instead of 30, or 450 LEDs in total instead of 150 with 5 volt strip. And even better, the addressable zones we have is 160, while with the 5 volt strip we have 150 because we only have 30 LEDs per meter. But here we have 96 LEDs per meter. So although the addressable zones are almost the same, 150 versus 160, we have 3 times the amount of LEDs. So that means the effect and the uniformity of the strip is going to be so much better because with 30 LEDs per meter, they're very far spaced apart. And with 96 LEDs per meter, you still have the same addressable zones, but there's 3 LEDs producing a lot more light and making it look so much better. So if you are evaluating 30 LEDs per meter 5 volt strip, I really, really encourage everyone. Uh-oh. The top cam battery has run out. Yeah, we can't use that anymore. Well, okay. This one has a dummy battery, so not worth there. But I really encourage everyone to look at that 96 LEDs per meter instead of the 30 LEDs per meter and just go 12 volt. Okay. Do I still have anyone with me? Or are you just all like listening carefully to what I say and not typing anything? Let's hope so. So, back to the calculations. For 5 meters, no, okay, well, we're doing a 10 meter scenario, huh? Let's do it 10 meters again to just compare it with the one above that. And then let's make it scenario 2B. That's going to be 20 meters. Back to school again. Hey, do you want to do like the perfect LED installations or not? That's the question. Let's see. 1, 2, 3, 4. Oh. So that's 1 strip, 2 strips, 3 strips, 4 strips. No, that's an end. Yeah. 1, 2, 3, 4, 5. Okay, so just to run ahead. To do this right, you're going to need 5 injection points. So that's 20 meters of LED strip. This is a lot of LED strip. So we can do the calculations again. Let's just copy this. So, did I do this right? Yeah. So we need 18.32 amps to divide over 5 injection points. And this is again where the 12 volt comes in. The amps are so much lower. They're more than twice lower. We have 2 edge injection points and 3 middle points, because we have front and end, and then middle, because we have 4 strips. That means we need to divide this times... Nope. There we go. Not times... Basically, I treat a middle and an end as the same as a middle. So then we have middle. That's 3 times middle. And we have a 4th. So we need to divide it by 4 times. Does that make sense to you guys? Because the front and back only see half of the LEDs as a middle. So that's 208 amps. That means that front will only see 104 amps. And this will see 208 amps. And then we're going to do this a few times. And here we need again 104 amps. Okay, hold on. So, we can already see, even if we compare this with the 10 meters of 5 volt LEDs, 60 LEDs per meter, yeah, that needed 13 amps. And here we have 20 meters. Okay, no, I'm an idiot. I'm doing it wrong again. No, wait, so yeah, one uses 50. Oh. Sorry. Oh, why? Why? My math isn't my strong suit either. I just bought 4 Dig Uno and 4 Dig Quad from Aldag, direct to Brazil. Cool. Sorry, I need to double these all up. I was already feeling too low. You know how that feels when something doesn't feel right, even if you're calculating something? Funny how that goes, huh? Still, it's not too bad. 4 amps is fine. I'll make sure to clean up this file and share it in the description and on my website. Yeah, using Excel is definitely better, but I wanted to show you what was going on. I wanted to run through it with you guys instead of just showing you, hey, this is how it works and just do this. I mean, yeah, I'll make videos doing that. If you want to do this, just do that. If you want this scenario, just buy this. Those are coming, but I wanted to have a video out there how to actually calculate this and why. So yeah, Excel is a lot better for this stuff, but hey. Yes, per 3 addressable. So, okay, then we need to calculate, and we're going to need this one for that, our cables. But now it starts becoming interesting because 12 volt has another advantage. Because here it says drop acceptable. And with 5 volt, we said, okay, we allow 10% drop, so that's half a volt. But 10% drop with 12 volt is 1.2 volts. So 10.5 volt is acceptable. Okay, so that's another advantage of going 12 volt. I'm on board with what you're doing and learning. Thanks for putting it together. Cool. Nice. I'm glad you guys are getting it, because I've been wanting to make a video like this for 2 months now, and I've started on it, and I've typed it out on Discord and on Reddit in a few posts and helping people out already. I was like, oh man. So I just decided today, let's sit down, let's do this. Everyone who's there, they can tell me if they get it or not. And, you know, ask your questions. Okay, so we have this, and that means that if we... let's fix this up real quick. And once these calculations are complete and we know what kind of cables we need, we're going to do some more Q&A, and then that's going to be the stream. So let's say another half an hour probably. Oh, okay, whatever. And then we need a few more of these. Mm-hmm. 6 meters, 11 meters, 16 meters, 21 meters. Right? Okay. You guys tell me when I'm doing it wrong, right? You should also make a video of you setting up a whole strip just like people would do, from start to finish, including power cabling down. Yeah. Well, I have some of that planned. That's why I actually got a whole stack of new LED strips to do this with. And that's all this 96 LEDs per meter stuff. But doing everything in a single video basically means you can't explain it. Because if I make a 10-minute video about flashing WLED and how to do that, if I add that to power calculations, power wiring, wiring it all up, flashing it, putting it up, etc., we're talking a 1.5 hour video. Nobody's going to watch that. So I'm going to see what I'm going to put in there or not. I'm missing 3 times the A. Oh, that's right. Thank you. See? It's good I have you guys. This setup from beginning to end would be perfect. Okay. You could do an LED series. Yeah. Makes sense. Okay. So, let's go back to our Chrome. And then let's go back to our power calculations again. Oh, let me just put this in the document real quick. I'll edit this document after the stream and add everything and then share it. Okay. We need 1 meter of 12 volt. I don't remember. Let's see, that's why I write things down. 208 amps. Okay. 208. Yeah, we probably don't. We said we were allowed to have 1.2 volt drop, right?
What are you afraid of?
Yeah, well, basically, if you use like a shoestring for the first wire, we're going to be okay. Minimum 28 AWG, whatever. It doesn't, the first wire doesn't matter. Now we're going to do 6 meters of 4.16 amps. So 6, 4, 16. 10 volt drop. No, that's not going to work. Okay, that's 1.6 volt drop. That's close. 1 volt drop. Okay, well, 1.3 volt, that's fine. So 19 AWG. Oh, wait, I'm not showing you. Sorry. So 19 AWG, 6 meters, 12 volt, 4.16 amps. We're left with 10.9 or 1.3 volt drop. That's fine. That's fine. Notepad. 19 AWG. So you can imagine if you were doing your 10 meter setup, this basically if you got two 18 AWG or just got 18 gauge cable or like 0.8 or 1 millimeter square, you'd be fine for a 10 meter setup. But let's continue, because we also need 4.16 amps at 11 meters. Okay, so we just change this one to 11 meters. Okay, that's not thick enough anymore. Let's go with 16 gauge, okay? Okay. Now we need the same amount, but then for 16 meters. We need a bit thicker, although in practice, whoa, what's this? Thanks for the donation, Ricardo Maranhao. Sorry if I butchered your name. Very sorry. I'm sorry. I don't even know what value that is. $10? Thank you for everything you do for the community. Thank you for donating, watching me, and maybe buying the controllers or using my affiliate links. Donations are very welcome. Thank you very much, but I don't know what to say about that. Thank you. I'm just going to say thank you and quickly continue. 16 gauge, yes. 1.7 volts drop, yeah. Close enough, close enough. See, now that we know what we actually need, we can make good estimations. And it doesn't come down to 1 or 2, 0.1 or 0.2 volts. It just comes down to actually calculating what you need, instead of going like, I'll use 28 gauge for everything, and then, these LEDs suck. You know. Okay, then we need 21 meters, Jesus, of 2 amps. Okay. 21 meters, 208. Calculate. Oh, that's fine. Can we go up? Yeah, that's okay. 16 gauge again. Oh, wait, didn't show it. Sorry. So, 21 meters, 12 volt, 208 amps. So, because it's an end, not a middle. And then 16 gauge. Okay. And here we can see that even though we're running... No, don't do that. Even though we're running 96 LEDs per meter, so that's 450 LEDs per meter, and the high power variant, and I had planned to maybe show that, but I'll do that in a separate video. Here you can see that even running those at 12 volt per 3 addressable is the downside. We still need less thick cables than we did in our 10 meter 5 volt scenario, because there we already needed 13 and 14 gauge. So 10 meters, you already need 13 and 14 gauge. Can you imagine if you ran 15 meters of 5 volt? You'd need like 10 or 8 gauge. That's like cables as thick as your thumb to make the calculations and reality work. So by going 12 volt and per 3 addressable, the thickest cable we need is only 16 gauge. Right? So that makes the project a lot more workable and doable. It's about $1.8. I don't care. It's awesome. Thank you very much. Brazil Real. Okay. Nice. Okay, so is that clear? Is this 12 volt per 3 addressable 96 LEDs per meter high power blah? Is that... Do you understand why I've fallen in love with this type of LED strip? It's a perfect combination or compromise between not running 5 volt 30 LEDs per meter because, let's be honest, that looks like shit, or running 60 LEDs per meter 5 volt because that makes for an almost impossible project, even especially if you go beyond 10 meters. You need so thick cables, it's just nuts. And then the downside of using this is per 3 addressable, but then again, if you have 20 meters of LED strip, you're not going to see that per 3 addressable. It's going to be way over there. So if you're doing that, use 5 volt or maybe 12 volt. It's not a lot of LEDs. It's both fine. If you use 5 volt for up to 10 meters, should be good. Next, beyond that, go 12 volt. It was mentioned in another forum where a 24 volt DC could be delivered and buck converters could be used to drop the voltage over greater distances. Yes, if you're for some reason stuck to using 5 volt LEDs, well, you made the wrong purchases, right? But if you're stuck with that, okay, yes, you can run basically a bus bar line of 24 volt all along the strip. And then each 5 meters you take a DC-DC converter and convert the 24 volt down to 5 volt. But these are not tiny DC converters. These are... Hold on. We're talking these guys, right? This is a 60 volt in, 5 volt, 15 amps out. So that's what you'd need because you're running a lot of amps and these are middle injections, so you need about 10. This is a giant heatsink, right? It doesn't get smaller than this. It needs to dissipate the heat of doing those DC-DC conversions. So yes, you'll have much thinner cables running along, but then you also need to pay for these things. And these are like $10, $15 a piece. And if you're running 20 meters, you're going to need 3 or 4 of those to inject it. Yeah, you bought the wrong strip, in my opinion. Hey, So yeah, you can do that, sure, yes. I understand that scenario, and there is actually scenarios where I'd use that myself. But if I had a clean slate and I could design the setup, I'd just go 12 volt per 3 addressable and not have to deal with any of that shit. Okay, I'm going to end the calculation part of this video. I'm really glad you guys stuck around with me. I'm not going to do this chart for 12 volt. I'm just going to click away real quick because holy shit. Yeah, so let's do a little bit of Q&A. How long have I been streaming? 2 hours? Have I been streaming 2 hours? Is my disc full yet? No. Okay. Is anyone still here? 79 people. Nice. 29 likes. Come on. You don't like my calculations? I get that you don't like doing homework. I get that. Okay, let's see. It was mentioned, yeah, we did that. Just out of curiosity, do you need sleep? And if so, how many hours of sleep do you generally need a night? To me, it seems like you hardly ever sleep, nor ever look sleepy. Actually, sleeping is a big hobby of mine. But when I sleep is kind of variable. I'm from nature, instinct-wise, I guess, I'm a bit of a night owl. If I don't watch my times, I live at night and not during the day. I don't know why this is. It just happens. But that doesn't really combine that well with a day job. So that forces me into some kind of rhythm. But definitely the days I do my day job and the days I am off, I'm online at different hours, and sometimes that kind of overlaps a little bit. And I try to get at least 6 hours of sleep every night. And most often in the weekend, I'll make it 7 to 8 hours. But yeah, it varies a little bit. Sometimes I get 5 hours. And if I don't do that too often, I'm okay. That's fine. So, hopefully that answers the question. I like them for small displays in Christmas tree. Haven't built anything else yet. Which one were you talking about? Oh, you mean the converters? Yeah, okay, sure. I can get that. And use power supplies half the way. Yes, so you can use multiple power supplies. And let me make a new drawing real quick. Sure. You can use multiple power supplies, but you need to watch out. So let's say you have a controller. Holy shit. Controller. And you have positive and negative. Going to a strip. Nope. Okay. Then if you want to add another power supply, P, and you have another strip here, you need to connect ground. I forgot the data wire. You need to connect data, but you do not connect... Jesus. Nope. Why isn't it working? But you do not connect positive, basically. You do connect ground. Does that make sense? So if you want to use multiple power supplies, you have to make split positive voltage planes, as I call it. So basically, positive is split here, so that the positive of this power supply can never reach here, and the positive of this power supply can never reach here. Does that make sense? Because otherwise they're going to try and balance, but their voltages are going to be different. That is going to be a really, really nasty scenario. Do not use multiple power supplies unless you know what you're doing. One of the ways to do it is by using split positive voltage planes, so you can keep continuing this. So if you have a third or fourth or fifth power supply, that's fine, but you need to chop off those positive planes, connect all the grounds together, and then it can work. But it's a lot of work, and you need to be really careful, because you kind of need to have a fuse here, you know, and you need to have a fuse here. And sure, yes, you can do it. I don't generally recommend it. Okay, I hope that answers your questions a little bit. Let's see. Forgive me, I'm not debating anything, just offering some point. I've only just begun working on this stuff. Cool. Yeah, that's the 24 volt buck converter. Sure. Yeah. What is the best way to control cold white and warm white strip in CCT mode over phone? I use a Queen LED quad, not DIG, or Deca, and then ESP Home on those with Home Assistant, and then you get a very nice GUI where you can just I guess I can show you that. Hold on, let me prepare that real quick. Okay, so here we have my Home Assistant, and if I turn off this one, that has an RGB CCT strip inside of it. So if I then turn the CCT port on, I get a nice GUI. See, I have my my light there, and I can set it to cold white or I can set it to warm white, or I can set it to like somewhere in between. So that's with a Quinn LED Deca, but a Quinn LED analog quad would work too. And in Home Assistant, you just get a nice GUI for that. Okay, hope that answers your question. You're not a night owl. You're Quindor. I'm the night owl. Well, you know what times I'm awake. So instead of running 10 meters straight around a room, you could run it up a corner and go 5 meters each way. This way you could use WS2815 60 LEDs per meter without any injection. Yes, you can run one WS2815 with a single injection point. So if you only need 10 meters in total and you can inject in the middle of those, then you can do it with only that point as injection. Yes, that's true. But then you can only use a maximum of about 10 meters. So, yeah. Must the PSU be the same type? If you're splitting positive voltage planes like we just talked about, it can be a different type. That's fine. If you're doing a single positive plane with multiple power supplies, it needs to exactly match. It actually needs to be made for that purpose. Don't do that. Do not do that. So yes, split voltage plane, that's okay. Are there any 12, 24 volt addressable RGB CCT strips yet? Addressable? No. There is 5 volt WWA, so warm white, cool white, and amber. SK6812. I have that on my website. So if you're looking for LED strip, we go to my website. And if we go down here, I'm working on a better way to categorize all this stuff. We have the What Digital 5 volt, 12 volt RGBW strip to buy. And in that article, I show you basically if you're doing low to medium density length, just get some WS2812B. High medium, you get some 12 volt WS2815, for instance. Long length projects, like we talked about, 12 volt WS2811. Digital RGBW, you get SK6812. And I added the 12 volt variant here. Digitally addressable white. The best digitally addressable white out there is the WWA strip I talk about. I have a special video about that you can watch. And that has 3 colors of white in it and it has a somewhat approachable CRI. It's not great, but it's okay. Yeah, so go to this page if you're looking to purchase LED strip, and it basically has it all laid out in what you need to do and why, or what you want to buy and why. Hey guys, what's up? Chris Wick. Hey. 45 likes. Yes. It's going up. Quinn, the old WS2811 12 volt strips, how much consumes for 5 meter 50 LED? I think you mean 60 LED. Hey, what the? Roberto Camarena, recommendation for LED string waterproof, like power supply protection for Dig Uno for rain, something like that. Let me get the first question first. Hold on. So for Fernando Calderon, if you look, I need to go to this scene again and then go to Chrome. If you look in my power tables, and there's a special 12 volt power table, if we're looking at per 3 addressable WS2811 12 volt 60 LEDs per meter, well, the wattages are right there. So I have different scenarios here. And then how much watts that uses. So you can calculate all the power needs and stuff like that yourself. Basically using the formula we just used. Let me link this in the chat. Okay, well, Ruperto, let's see here. For LED strings, waterproof, like power supply protection for Dig Uno and outdoor for rain, something like that. Okay. If you really want to make it outdoor, You have to get one of those project boxes that is waterproof. Outdoor case LED waterproof. I'm not sure how to show you what I mean. Let me show you my Chrome. So there's different types you can get. Basically, for instance, like a box like this. And they have also bigger boxes or a box like this. You can drill in glands like this stuff. So you can input and output cables in a watertight manner. Like for instance this way. And then you can put the power supply and the Queen LED Dig Uno or Dig Quad controller in that. Then you run your cables using X-Connect cables, I would advise. There we go. Let's open this image. Yeah, so these are cables, and you can get AliExpress vendors like Reiwu or others to make your cables or your LED strips with these cables watertight attached, and these are watertight connectors. So I have some X-Connect cables, and using X-Connect you can make a connection to the LED strip. So you run an X-Connect cable from the watertight power box through a gland, then to the LED strip, and there you do X-Connect to X-Connect, and then you have a watertight connection there. Then you run IP67 or 68 LED strip. Let me see if I... There we go. We have an article for that. So we have IP65. So IP20 or IP30 is just... Oh, sorry. No protection on there. Perfect for indoor, etc. If we then want a bit of water protection, that's IP65. So that means there's epoxy on top of the strip. But it's not fully watertight, but usable in a lot of situations and often nicer to work with. And then we get to IP67 that has a silicone sleeve over the whole LED strip, so it's fully encased. That is perfect for outside and perfectly watertight. And especially if you get one with the X-Connect connector already pre-attached to it, perfect, all watertight. And then you can go the Uber route, and that's IP68, and that basically combines IP65, so epoxy, and IP67, so that sleeve together. So you get IP68, so that's a silicone sleeve filled with epoxy. No water is ever getting near it. But again, you need those X-Connect connectors and stuff like that. I hope that explains your question, or helps you with finding the right stuff. A CG 1500 case is popular. See, thanks, Miguel. CG 1500. What? Case? No, not shopping. Oh God. Okay, yeah, exactly. One of those boxes. Here's one with a sort of controller in there. Those kind of boxes are often used for this kind of stuff. Absolutely. Okay, yes. So I'm talking about the strings, not the strips, the pixels that are by one addressable. Ah, you mean like this kind of stuff? So like these kind of pixels, you can get those with the, so not with the little JST connector on there, but if you go Ray, I think Reiwu has them. Yeah. So Reiwu, that's a known name on AliExpress, sells them with those X-Connect connectors already attached to the pixel string. So then you don't have to do that yourself, and it's all watertight. And well, that just works. It's a bit more expensive, but that way you can get it perfectly watertight. If you put it in an enclosure, you will have a problem with heating. It depends on the amount of watts and amps you're going to use. If you're going to use a lot, yes, you need to have some kind of ventilation in the enclosure, which is then set up in a watertight manner. Yeah, but there's ways to do that. That's and let me check the chat. I'm talking about things that they just will one, yeah. With 35 watt, it's hot. Yeah, then you'll have to arrange some ventilation and make sure that's watertight. There's special grates you can get for that, basically with the lamelles pointing down, so air can go through, but water can't get in, and have a little bit of a fan in there. But yeah, you'll have to design that, I guess. I'm not sure you can buy that prefabricated, or what price it would be. Hold on. So my voice is cutting out, so I have time for 1 or 2 questions more, and then we're going to cut off the stream. Do I need separate wire that has 3 strands for data? Or can I just use black and red AW18, which I already have, and just cut another strip of either red or black off? Yes, if you mark those well, you can just add a 3rd cable, that's fine. If you get the X-Connect cables, cable. Yeah, for instance, like this, this is a 1.5, this is already a 3-core. So these X-Connect stuff, or the Reiwu style, whatever, they come with 3 wires inside of the cable already, and those are often AWG18 also, so that works out good. Oh man, okay. We're getting to the end of the stream here. I'm getting tired. Let's see, let me increase the font. Yes. Thank you for your time, Quinn. No problem, Fernando. I hope that answers some stuff. Hey, Quinn, IT guy here. Cool. Hello from Texas. Well, hello from the Netherlands. Yeah, I'm going to cut that off. Thank you for the super chats. That is really awesome. Oh, do you have any tips for using LED effects? Can get a cool pattern. I haven't used LED effects a lot, so don't really think I can help you there. Yeah, but I'm going to cut off the stream. Maybe if there's interest, let me know down in the comments, and I'll do more of these streams going through LED setup scenarios and actually calculating what you need for that, instead of just doing some guesswork, using some random cables and hoping it all works out and doesn't burn down. Hey, I'll have the text file linked in the description. I'll have some QuinnLED.info links in the description where to buy LED strips or my controllers and stuff like that. And I hope everyone enjoyed. I'll chat with you on Discord. I hope about my dig. Sure, that's fine. Thanks for watching all, and I'll catch you guys in the next one. Bye-bye.